Hello everyone, it's JL 3D Printing here. Now I've got another video here and I'm going to be showing you a breakdown of a Hotend. So all the singular parts of a Hotend, I'm going to take it apart and show you. You can currently see it took apart. So I'm going to show it you, and as we go along I'll build it back together so we're left with a full Hotend at the end. And I'll explain all the different parts and what they do, what their function is. Okay, so I hope you like these videos. Please let me know in the comments what you like about them, what you don't like about them, what I can improve on. I need the help to improve. And if you like the videos, please like them, subscribe to my channel, it will really help me. If you can put the bell notification on, it'll be even better because you'll get a notification every time I make a new video. Let's get straight into it. So here we have a heat block. Now I'm pretty sure there's no point going left to right or right to left because it's easier for your understanding to start with this, I think. So this is called a heat block and it's heated up by this red wire which is connected to a heat cartridge, which you can see here. Heat cartridge heats up, causes this block to heat up, and then you have a thermistor here which is in the white wire and it plugs in here to the heat block. You can see it going in there. What the thermistor does is it's a resistor which changes resistance based on heat, so it controls how much power goes to the red wire to heat the block up. So when it gets hotter and closer to the temperature that you set it to, less power will go to heat it up, and then it will get to the point where there's no power going in, so your hot end will stay at that temperature, and if it drops, obviously the resistance will drop again, and so the heat cartridge will come back on, and it will just keep doing that and going on and off, and keeping your hot end at a stable temperature that you set it to. Okay, so here we have a heat break. Now the heat break screws into the hot block like this. The heat break is designed to keep the heat broken, keep it apart, so it keeps this bit here cool, and then the bottom bit that screws into the heat block keeps that bit warm. Now you can see there's like a little throat here that helps to break the heat, which is why it's called a heat break. So what it means is the top bit won't get as warm as the bottom bit, so as the filament's coming through, it means that the filament won't melt here and then start to cause jams. So it means the filament will only melt when it gets to the bottom bit and into the heat block, which is where you want it. So it prevents the filament from heating where you don't want it and then causing jams. So this is designed to make sure that the filament melt zone is really short. So it's only melting and then going straight out. So it just keeps the filament path short for the melted filament. So what happens is the heatsink will screw onto here. And it means that any heat that's in the heat break will go from the heat break and it will go into the heatsink. Now most printers will have a fan on the heatsink, so the fan will keep the heatsink cool, which makes sure that a high temperature gradient is kept, which means that the heat coming away from the heat break and into the heatsink will be at a high rate all the time. So not all hot ends actually have a fan on the heatsink. There's a Slice Engineering Magnum that the heat break is designed so it doesn't need a fan, but this one does need a fan. So a fan will keep this cool, and then it will make sure that all of the heat goes away. So what it means is that the top bit of the heat break is kept cool, and so only the bottom bit inside the heat block is kept warm, so it stops jams. Next, now this is dependent on a Bowden or a direct drive system. Direct drive would just be this and the extruder would mount straight on here, but a Bowden system would first have this, which will screw into there. So this screws into here, and then the Bowden tube would go into there and it would push in. Now at the moment the Bowden can't physically be pulled out because this black is pushed all the way out. In order to get the tube out, you'd have to push this black thing in and then pull the tube. So here we have a thing called a collet clip, which goes on here and prevents the black thing from getting pushed in, so it just keeps the tube locked in. Now the last thing that will go on is a nozzle, and the nozzle will screw into here. And the nozzle is simply just a piece of metal that the filament will go into, but because there's only a really small hole on it, the filament will go inside of it, it will melt and it will stay inside, and then only a little bit will get let out. So this controls how much filament comes out. All of these are 0.4mm nozzles, so it means that the filament that is extruded will be 0.4mm wide.
So the filament will just go into here, melted, and then it will come out as 0.4 millimeters in this case. Now we have three different nozzles, three different materials. So you've got this one, which is brass. Now it has a high thermal conductivity, but brass is really weak. So if you've got abrasive filaments like wood filament, you've got carbon fiber filament, and I'm pretty sure metal blend filaments are quite abrasive. It will just end up destroying this nozzle eventually and wearing it out wider than 0.4, which is why hardened steel like here is used, because they're strong and they've got a high wear resistant, so it means that filaments won't wear them out as much, so they're good for abrasive filaments. And in the middle we have a copper plated nozzle. Now the copper plating works as like an anti-stick, so it's good for printing stuff like PTG that likes to stick on the nozzle. Because of the non-stick, the PTG won't end up sticking and melting and then like glooping on the end of the nozzle and then ended up burning. So the non-stick just means that you won't get PTG sticking to your nozzle, and so that's why a copper plated nozzle is good. Okay, so here I have showed you every single part of a hot end. I've explained what every single part of the hot end does, and I've built the hot end back to how it would be. And so I hope this guide will help you when you're troubleshooting issues, because if you've got issues that maybe your filaments jam in, then maybe you now know what you need to look for within the heat break area. Maybe that's come loose or something, could cause it. Yeah, so I hope this guide will help you now be able to figure out issues with your printers, and I hope you like the video. So please let me know in the comments and subscribe if you can. I'd really appreciate that. Hope you like the video, and I'll see you in the next one.